Hello, in this video, we'll be solving this rational inequality. We want to find the values of x that satisfy this rational inequality. It's the same thing as saying you should find the solution set. So if we look at this, we'll realize that some steps of this problem have already been carried out in the sense that we can see that the numerator is already in a factored form, x plus 8 all to power 8. And already we have the rational function on the left hand side and we have 0 on the right hand side. So what is left is we can factorize the denominator so that we have x plus 8 all to power 8. And we need to factorize this. This clearly is just x plus 3, then x plus 4. This is less than equals to 0. And for solving rational inequalities of this form, we use the critical value method. So here we can find the critical values. The critical values are the zeros of the numerator as well as the zeros of the denominator. So from the numerator, we will have x equals to minus 8. And from the denominator, we will have x equals to minus 3 and x equals to what? Minus 4. Now these are the critical values. So let's go to the table to create our table. We need to put our critical values. So the smallest is minus 8. So minus 8, let's say minus 8 is somewhere here. And we have minus 4. Then we have minus 3. So we can draw a line this way, line, this, and this. Now, let's put the factors. What are the factors? These are the factors: x plus 8 all to power 8, then x plus 3, and here we have x plus 4. Now, don't forget, this is like from minus infinity, and this is also going to infinity. Now, what is the procedure? We have to open all the zeros, all the critical values coming from the denominator, because if x cannot be minus 3 and x cannot be minus 4. So it means here we have to leave this open, both at minus 4 and minus 3. But at minus 8 is the critical value coming from the numerator. So it can be closed because we have equal to 0. So we'll leave this closed. Okay, so now we take a number just to know the sign of we'll do the sign test here. We take a number between minus infinity and minus 8. So here, first of all, look at this one. This one, you have an even power here. So everything is going to be positive all through in all of the intervals. Now, if you take minus 9, we'll try to mark what is minus 9 plus 3. So this is going to give us what? It's going to give us minus 6. So it's negative. Put minus 9 here. Minus 9 plus 4 is also minus 5, also negative, right? So so it means you have, this is a positive, you are dividing by this times this will be positive, right? So this is the numerator and this is the denominator. So you have positive over positive. So everything is still going to be positive here. Now, you take a number between minus 8 and minus 4. So we can take minus 5, or yeah, we can take minus 5. If we take minus 5, you have minus 5 plus 3, which is minus 2. So here is negative. Put minus 5 here, you have minus 5 plus 4, which is still negative. So this is still negative. So we will see that this is still going to be positive here, because you have a positive number divided by a positive number, because here will become positive because you have negative times negative. Then here between minus 4 and minus 3, we can try minus 3.5. If you put minus 3.5, minus 3.5 plus 3 It's still going to be minus 0.5. So it's still minus here. But minus 3.5 plus 4 is going to give us 0.5, which is a positive term. Now, if you put these three signs together, plus, minus, minus, definitely the outcome will be minus. Okay? And here, now you take a number which is bigger than minus 3. For example, you can take 0 or you take minus 2. So you put it here, minus 2 plus 3 is going to be 1, so it's positive. If you put minus 2 here, minus 2 plus 4 is going to be 2, which is still positive. So everything here is positive. Now, what is our interest? Our interest is to take the part that is what? Less than or equals to 0. What does it mean? It means it's either negative or it is what? 0. So the solution set will be what? First of all, look at where we have negative. So this is, we have negative in this interval, which is, but don't forget, here is open, so it will be minus 4 open to a minus what? Minus 3. Now, from minus 4 to minus 3, what do we have? We have negative, but we have equals to 0. Now, if we look here, at what point can we get 0? You see, at minus 8, because don't forget that this minus 8 is closed. So it means at minus 8, this rational inequality will be equals to 0. Though, between minus infinity and minus 8 open, right? What do we have? We have positive. So we can't take it. But at minus 8, you have 0. So, and 0 is included here. So we have to union what? Singleton sets. And what is that set? Singleton set of minus 8. So this is the solution set for this problem. So any values of x you take from here is going to satisfy this rational inequality. So if you take, for example, if you take x to be minus 8, it's fine, because at minus 8, you're going to get 0, which is good. But any number you take outside minus 8, you take any number in this from minus 4 to minus 3, you are going to get negative, which is still fine. So this is the complete solution. This minus 8 is very important. You don't leave it out. You have to include it, because at minus 8, we have what? We have 0. I hope this video is clear. Thank you for watching.